Imagine looking up at the night sky and realizing that everything you see, all the stars, planets, galaxies, is just a tiny fraction of what's really out there. What if I told you that around 95% of the universe is made of things we can't even see? No light, no sound, no way to touch it. And yet, it's holding galaxies together, expanding space itself, and rewriting the rules of physics. Hi, I'm Shafat, and welcome to Space Pulse. Today, we're diving headfirst into the biggest unsolved mysteries of the cosmos. From invisible forces that shape reality to sudden radio signals from across the galaxy, this journey will change how you see the universe forever. Buckle up, because this is not your usual science class. This is a story of darkness, discovery, and the deep unknown. Chapter 1. The Hidden Architects. Dark Matter and Dark Energy. Let's start with one of the most mind-blowing facts in modern physics. Everything we can see, stars, planets, gas clouds, even black holes, makes up only about 5% of the entire universe. The rest, we don't really know. Scientists call it dark matter and dark energy. But those are just names. Truth is, we don't know what they are. Dark matter is like an invisible skeleton. It doesn't emit or reflect light, but it has gravity, and it's everywhere. We discovered it by accident. Galaxies weren't spinning the way they should. According to Newton's laws, the outer stars should be flung away like children on a broken merry-go-round. But they weren't. They held together. Why? Something unseen, something heavy, was keeping them in place. Gravitational lensing, another clue. That's when light bends as it passes massive objects. In some galaxy clusters, the light bends way more than it should based on visible mass. Then there's dark energy. This one's even weirder. In the late 1990s, astronomers measured the light from distant exploding stars, called supernovae, and made a shocking discovery. The universe isn't just expanding, it's expanding faster over time. That's like throwing a ball into the air and watching it speed up instead of slow down. It made no sense, and so they called the culprit dark energy. Together, dark matter and dark energy make up 95% of the cosmos. But despite decades of research, we still don't know what they actually are. Physicists have hunted for exotic particles like WIMPs and axions in giant underground detectors. So far, nothing. We've tried smashing atoms in the Large Hadron Collider. Still nothing. We've built powerful telescopes like Euclid and the Vera Rubin Observatory to map the dark universe. We hope they'll help, but hope is all we have right now. And here's the kicker. Without dark matter, galaxies wouldn't form. Without dark energy, the universe might collapse. These invisible forces aren't just curiosities. They're essential, so we're left with questions. Is dark matter made of particles, or something else entirely? Is dark energy a property of space itself, or a sign that Einstein's gravity theory is incomplete? Could it be both? The truth is, we don't know. But we're trying, and the closer we look, the more mysterious it gets. Chapter 2. Strange Objects, Black Holes, Neutron Stars, and Anomalies. These are regions of space where gravity is so strong, not even light can escape. We've all heard about them. But did you know? We still don't understand them. At the center of a black hole is something called a singularity, a point of infinite density, where the laws of physics just break down. What happens there? No one knows. Time might stop, dimensions might fold. Some scientists think black holes could be gateways to other universes. Others think they might evaporate through something called Hawking radiation. But we've never seen that happen. And what about neutron stars? These are the crushed cores of dead stars, so dense that a single teaspoon would weigh 1 billion tons. But there are weirder ones too. Magnetars, with magnetic fields 1 trillion times stronger than Earth's. Occasionally, they release bursts of energy that shake space itself. Then there are fast radio bursts, or FRBs, mysterious radio signals coming from deep space. Some repeat, some don't. We've detected them from billions of light years away. For a while, people thought they might be alien signals. Now we think they might come from magnetars or colliding neutron stars. But again, no solid answers. Even our spacecraft have been confused. The Pioneer anomaly baffled scientists for years. The Pioneer 10 and 11 spacecraft were slightly slowing down as they drifted away from the Sun, slower than expected. At first, people thought it might be a sign of new physics. Later, it was maybe heat pushing them back. But the debate lasted decades. Then there's the missing antimatter problem. In the early universe, matter and antimatter should have been created in equal amounts. But for some reason, matter won. Antimatter vanished. Why? We don't know. But we should. Because it's the reason we exist at all. And here's a fun one. The dwarf galaxy problem. Our models say the Milky Way should be surrounded by hundreds of small satellite galaxies. But we only see a few dozen. Are they too dim to spot? Is dark matter to blame? Or is our model wrong? Mysteries like these aren't just fun stories. They challenge our understanding of gravity, time, and the fabric of reality. Chapter 3. Signals, shadows, and the possibility we're not alone. Finally, let's look at the mysteries that feel the most thrilling, and maybe the most personal. What if we're not alone? In 1965, people across 6 U.S. states saw a bright fireball streak through the sky and crash into the woods near Kecksburg, Pennsylvania. Witnesses described a bell-shaped metallic object. The military showed up. The area was sealed off. The government said it was a meteor, or maybe a Soviet satellite. But no one really knows. Decades later, it's still called America's Roswell. In 1977, a radio telescope picked up a brief, intense burst from deep space. It's known as the WOW signal. We've never heard it again. Was it aliens? A natural cosmic event? A glitch? To this day, it remains unexplained. There are even stranger ideas floating around, like white holes. Think of them as black holes in reverse. Instead of sucking things in, they spit matter out. They're predicted by Einstein's equations, but we've never seen one. Some scientists think a white hole could be what we see at the other end of a black hole. Maybe even a way to travel between universes. And speaking of other worlds, there's something tugging at the outer edges of our solar system. Strange orbital patterns suggest there's a giant planet, maybe 10 times Earth's mass, hiding far beyond Pluto. We call it Planet 9. We haven't seen it, but its gravitational fingerprints are everywhere. And if it's real, it could reshape everything we know about our cosmic neighborhood. Meanwhile, rogue planets, giant worlds that drift through space without a star, are everywhere. Some are massive, some are icy. Some may even have moons or underground oceans. Could life exist there, far from sunlight? Zoom out even more, and we hit the multiverse theory. The idea that our universe is just one bubble in a sea of universes. It's wild, but some patterns in the cosmic microwave background, the afterglow of the Big Bang, suggest strange cold spots or alignments that don't quite fit. Could those be scars from another universe brushing against ours? Closer to home, we see massive structures like the Fermi bubbles, giant gamma-ray clouds extending above and below our galaxy. Are they remnants of ancient black hole eruptions or signs of something else? Then there are ultra-high energy cosmic rays, particles moving so fast we don't know how they exist. They hit Earth with more energy than anything we can make in a lab. But where do they come from? Supernovae, alien technology? We just don't know. Every mystery we solve seems to uncover 10 more. But maybe that's the beauty of it. Dizzy closing statement. The universe is vast, ancient, and, so far, mostly unknown. But with every telescope we launch, every equation we challenge, and every mystery we chase, we get a little closer to understanding it. I'm Shafat, and this was Space Pulse. If you enjoyed this journey through the strange and unknown, give it a thumbs up, hit that subscribe button, and tell me in the comments, which of these mysteries do you want us to dive deeper into next? Thanks for watching, and keep looking up.